Who will be the first to reach Alpha Centauri, the nearest star system beyond our sun? That's the question that's been fueling a new space race. But this isn't your grandparents' space race. Oh no. This is a challenge on an interstellar scale. Alpha Centauri is a triple star system, home to 3 stars whose names you might recognize from the night sky: Rigel Kentaurus, Ptolemy, and the closest star to our sun, Proxima Centauri. It's nestled in the constellation of Centaurus, and it's a whopping 4.3 light-years away. That's about 25 trillion miles or 40 trillion kilometers if you prefer. Now, if we were to hop on the fastest spacecraft ever launched by humanity, the Parker Solar Probe, we'd be looking at a journey of over 6,000 years. That's longer than all of recorded human history. So it's clear that we need a new approach. We need to push the boundaries of our technological capabilities to even consider making this journey, and that's where the Alpha Centauri challenge comes in. It's not just about being the first to plant a flag on a distant star system. This is about pushing humanity forward, developing technologies that we can't even imagine yet. It's about the journey, not just the destination. We're talking about engineering feats that would make the Apollo moon landing look like a high school science project. We're talking about harnessing the power of nuclear propulsion, antimatter engines, or even light sails powered by giant lasers. The challenge is immense, but the rewards? They're literally out of this world. The journey to Alpha Centauri is not just a race, but a testament to our technological prowess and our enduring spirit of exploration. It's a challenge that asks us to look beyond our own backyard, to reach out into the cosmos, and to strive for what might seem impossible. And who knows, maybe one day we'll be able to call Alpha Centauri our second home. Why is Alpha Centauri, out of all the star systems out there, the prime target for interstellar travel? Alpha Centauri is not just one of many star systems in the vast cosmos. It's a triple star system, featuring 2 sun-like stars, Alpha Centauri A and B, and a smaller red dwarf called Proxima Centauri. The latter is the closest star to our sun, at a distance of just over 4 light-years away. But it's not just the proximity that makes this system intriguing. Let's talk about Proxima Centauri, the smallest star in the system. While it might not be as bright or as large as its counterparts, it holds a significant allure. Twirling around this red dwarf is a planet named Proxima b. This is no ordinary planet. It's roughly the same size as Earth and resides in what astronomers call the habitable zone. This is the Goldilocks region around a star where conditions could be just right for liquid water to exist on a planet's surface, and where there's water, there could potentially be life. So imagine the implications. If we could reach this star system and find life on Proxima b, it would be a monumental discovery, reshaping our understanding of the universe and our place in it. It would mean that we are not alone. It would mean that life could be a common phenomenon in the cosmos, rather than a rare exception. But it's not just the potential for extraterrestrial life that makes Alpha Centauri attractive. The system's proximity to us also makes it a logical first step in our journey to the stars. It's the closest star system to our own, making it the most achievable target for our first interstellar voyage. The discovery of Proxima b fuels the race to Alpha Centauri, promising a possibility of life beyond our own world. In this race to Alpha Centauri, who are the key players? Space, the final frontier, and the journey to Alpha Centauri is not a solitary pursuit, but rather a collective effort of nations, companies, and bright minds from across the globe. First on our list of key players are the established space agencies. These powerhouses of space exploration have been venturing into the cosmos for decades, and their expertise and resources are second to none. NASA, the European Space Agency, and the China National Space Administration are all in the running, each developing deep space propulsion technologies that will revolutionize our journey to the stars. But it's not just the giants of space exploration who are striving for the stars. In the 21st century, private companies have entered the race, bringing innovative ideas and a fresh burst of energy. SpaceX, Blue Origin, and a host of others are pushing the boundaries of what's possible, funding and developing interstellar travel concepts that once belonged only in the realm of science fiction. One such private venture that deserves special mention is the Breakthrough Initiative's Project Starshot. This ambitious initiative aims to send ultralight nanocrafts to Alpha Centauri within a generation, propelled by ground-based light beamers. This revolutionary concept, if successful, could change the face of space exploration, bringing the stars within our reach. But Project Starshot is not without its challenges. Several engineering hurdles need to be overcome before such missions can be launched, and the project is committed to transparency and open access, offering research grants and funding to support scientific and engineering advancements. So, as we stand on the precipice of a new era of space exploration, who will be the first to reach Alpha Centauri? Will it be the established space agencies with their decades of experience and vast resources? Or will it be the private companies, with their innovative ideas and determination to push the boundaries of what's possible? The answer is not clear, and perhaps it's not meant to be. For in the race to Alpha Centauri, it's not about who reaches the finish line first. It's about the journey, the discoveries we make along the way, and the knowledge we gain about our universe. The race to Alpha Centauri is not a solitary pursuit, but a collective effort of nations and companies. It's a testament to the power of human ingenuity and our unquenchable thirst for discovery. And whoever reaches Alpha Centauri first, we all win. What will propel us to Alpha Centauri? This isn't just a question of curiosity, it's the fundamental challenge in the race to reach our nearest stellar neighbor. We've mastered the art of rocket science to a significant extent, but our traditional chemical rockets, the workhorses of space exploration, simply won't cut it for interstellar travel. Why, you ask? Well, it all comes down to fuel efficiency, or rather the lack thereof. Chemical rockets rely on the principle of expelling propellant at high speeds to push a spacecraft forward, the old action-reaction law at work. But to reach the kind of velocities needed for interstellar travel, we'd need an astronomical amount of fuel, and the more fuel you carry, the heavier your spacecraft and the more energy you need to move it. It's a vicious cycle that leaves chemical rockets out of the running for the interstellar race. So what's the alternative? Scientists and engineers are exploring a range of advanced propulsion concepts that could potentially overcome these limitations. One such concept is nuclear thermal rockets. Instead of burning chemical fuel, these rockets use nuclear reactions to heat a propellant and expel it at high speeds. This could potentially offer much higher fuel efficiency than chemical rockets, but it also comes with its own set of challenges, such as managing the heat and radiation from the nuclear reactor. Another intriguing concept is fusion drives. Fusion, the process that powers our sun, has the potential to provide a virtually limitless source of energy. A spacecraft powered by a fusion drive could potentially reach speeds much higher than what's possible with chemical or nuclear rockets. However, we're still a long way off from harnessing fusion energy in a controlled and efficient manner. Then, there's the holy grail of advanced propulsion: antimatter engines. In theory, antimatter offers the highest energy density of any known substance. When matter and antimatter come into contact, they annihilate each other, releasing a huge amount of energy. This could propel a spacecraft to near-light speeds, making interstellar travel a reality. But there's a catch. Antimatter is extremely difficult to produce and store, and even a tiny amount could cause catastrophic damage if not handled properly. The engineering challenges we face in developing advanced propulsion systems are immense, but so are the potential breakthroughs. The journey to Alpha Centauri is a daunting one, but it's also an opportunity to push the boundaries of our scientific and technological capabilities. Who knows? The race to reach our nearest star might just drive us to discover the next big leap in propulsion technology. Let's keep our fingers crossed and our eyes on the stars. What does the journey to Alpha Centauri entail? Imagine embarking on a journey, one that extends beyond the boundaries of our solar system. A voyage that even light, the fastest thing in the universe, would take over 4 years to complete. This is the monumental voyage to Alpha Centauri. But what does this journey truly entail? First, let's consider the travel times. Even with advanced propulsion technologies such as nuclear or fusion drives, we're still looking at travel times that span decades, if not centuries. To put it in perspective, if we were to travel at the speed of the fastest spacecraft ever launched by humanity, the Parker Solar Probe, it would take us about 6,700 years to reach Alpha Centauri. That's longer than all of recorded human history. And the challenges don't stop with propulsion. There's the question of life support for these prolonged journeys. How do we ensure that the crew, or perhaps even multiple generations of a crew, have the resources they need for survival? Food, water, air, these are all things we take for granted here on Earth, but in the void of space, they become precious commodities. Then there's the issue of radiation. Space is filled with cosmic rays and solar radiation that can be harmful, even lethal to humans. Any spacecraft heading to Alpha Centauri would need effective radiation shielding to protect its passengers. These challenges might seem insurmountable, but remember, every great journey begins with a single step. And sometimes, that step is a giant leap into the unknown. The road to Alpha Centauri is long and fraught with challenges, but it's a journey worth undertaking. For it's not just about reaching another star, it's about the technological advancements, the scientific discoveries, and the unity of purpose that such a journey can inspire. It's about what we can become when we dare to reach for the stars. The road to Alpha Centauri is long and fraught with challenges, but it's a journey worth undertaking. Who will win the race to Alpha Centauri? This question has been on the minds of scientists, space enthusiasts, and even everyday people ever since we discovered the potential of this star system. But the truth is, it's not a quest that can be won single-handedly. The journey to Alpha Centauri, the nearest star system to our sun, is an immense challenge that'll likely require the combined efforts of nations, space agencies, and private companies. It's a venture that demands not only advanced technology, but also significant financial resources. This is a race that is not about who gets there first, but about how we can collaborate, innovate, and push the boundaries of our capabilities. As for when we might reach Alpha Centauri, it's a tricky question. With our current technology, even the most optimistic estimates place us decades away. But who knows? With the pace of technological advancement, we might just surprise ourselves. After all, a mere 6 decades ago, the idea of a human setting foot on the moon was pure science fiction. The future of the race to Alpha Centauri is filled with possibilities. We might see multi-generational starships, propelled by light sails, or even microscopic nanocrafts, zipping through the interstellar medium. Each passing day brings us closer to these realities. But let's remember, the race to Alpha Centauri is more than just a competition. It's a journey of discovery, a testament to human ingenuity, and a unifying goal for humanity. It's about reaching out to the stars, seeking answers to our most profound questions, and perhaps finding new questions to ask. After all, isn't that what exploration is all about? The race to Alpha Centauri is a journey we're all part of. This grand adventure, this challenge that lies 4.2 light-years away, is not just about a single spacecraft or a solitary expedition. It's about the collective efforts of humanity, pushing the boundaries of our knowledge and technology. It's about the quest for answers, the pursuit of the unknown, and the exploration of possibilities beyond our wildest dreams. So, dive into this fascinating world of interstellar travel. Read about the pioneering projects aiming to conquer the vastness of space, like Breakthrough Starshot and its ambitious plan to reach Alpha Centauri within a generation. Follow the work of international space agencies and private companies, each contributing their unique piece to the cosmic puzzle. And remember, every new discovery, every technological breakthrough, every step we take towards Alpha Centauri is a step forward for all of us. So let's fuel our curiosity, expand our horizons, and dream of the day when we, as a species, will finally reach the stars. Stay curious, keep exploring, and together we might just reach the stars.